For this video, I'm going to discuss how you can facilitate the Explore portion and summarizing section of Lesson 10A, Rewriting Quadratic Expressions in Factored Form, Part 4, Unit 7, Day 18. The focus question of this lesson is how can we rewrite an expression in factored form? Now, you may be noticing that students have been writing expressions for a while in factored form. However, in this lesson, we're taking it to the next level because A is going to be greater than 1 for these expressions. So the first thing students will be asked to do for the Explorer is they're asked to take the factored form and rewrite it as standard form with these coefficients, with an A greater than 1. Students should be familiar with this, and this should be pretty straightforward for them to work through. But the key point of this is taking time to really solidify an understanding of the observations and patterns that students notice and giving them these key ideas so that when they go to the next slide, where they're asked to rewrite from standard form to factored form, they're able to kind of start to think about how they can do that. First, we want students to notice that the first term is the product of 3x and x, is the product of those two first factors. The last term is the product of these two last factors, and we want them to draw conclusions about the middle term, specifically around the fact that it's not just the sum of the two constants in the factored form, but that you actually have to find the sum of 3x times 4 plus 1 times x. And once they kind of start to deepen their understanding of that, it's going to support them when they come to this slide, and it's going to prevent them from having misconceptions. But we're still going to see misconceptions because students are very used to factoring when this is just a 1 in front of the x squared. So I went ahead and I created a Desmos lesson for this, and this will be shared below the video. And you will obviously have many more students, and you will have many more student work samples to pick through. And you can decide what works best for you when facilitating the summary conversation of this factoring activity. So within the Desmos lesson, there is a slide, and it just asks them to explain or show how they rewrote 5x squared plus 20 at 1x plus 4 in factored form. There's the table here, like the regular lesson, and then they have a specific slide to do this. And I put this in here in anticipation of the summary question because this is the question that I'm going to feature for the summary discussion, and I wanted students to specifically show exactly how they were finding this so I can choose work. So like I said, I'm choosing to feature misconceptions because for this lesson, I'm less worried about the different strategies right now and more about really clarifying misconceptions that exist about when you're factoring with a greater than 1. And I'll show you the misconceptions that can arise. So I snapshotted the 3 students' work and I'll show you the work, but I first featured the correct strategy and then I featured 2 misconceptions. And for the correct strategy, I'm just going to ask students what do they notice and what do they wonder about that strategy. And again, I'll show you this. Let me just present right now. We'll get deeper into what we want them to see. But then we get to what is the misconception, and we have one misconception here that might arise and another misconception here that might arise. Okay. So let's talk a little bit about this slide. So here's an exemplar response. What do you notice about this student strategy? I noticed they use diagrams to support their thinking. I noticed they use guess and check because they first tried to do 5x and 2 and x and 2, and they realized that that doesn't add up to 21x when they added the 10x and the 2x. So they tried again, and they were able to find a pair of factors that will combine to make 5x squared plus 21x plus 4. Why did they choose to write 5x and x here? Well, they knew automatically, why did that not change from strategy to strategy? They knew that there had to be a 5x and an x because they had to multiply to that 5x squared. There was no other combination of factors they could put here. Okay, interesting. So they knew this had to be 5x squared. They knew this had to be a 4 here, and there were 2 possible factors that can multiply to 4. So they tried 2 and 2, and then they tried 1 and 4, right? And so again, students may bring up these noticings, or you may start to pull them out of them because we really want to dive into these specific things. So we have, and we can even use the annotation features on Zoom. So we have the 4 here, and we have the 4 here, and we have the 4 here. We know that that cannot change. And then we also know that the 5x squared cannot change. So no matter what, you can put that into your box, and you can automatically start thinking about the factors of those. So this had to work, or this had to work, or this would not be factorable. And then they were able to kind of notice 1 times x and 4 times 5. What would happen if they reverse this? If they put the 4 here and the 1 here? Well, they wouldn't have been able to add up to 21, so they might have had to try another combination. And that may happen in situations. So students may have to try many combinations before they find the correct factors. Okay. So you have this. What do you wonder? I mean, students might say, I wonder how they knew what numbers went in these boxes. I wonder how they knew to find 1 and 4. And that's where you can either allow that student to explain what they thought based on pretty much just elaborating on what I just said, or you might have students, somebody else in the class explain, depending on how confident other students are with this concept. Okay. So we really get this deep understanding of here. So now we get to here. Okay, so let's look at what this student did. I noticed the first 2 values have to multiply to 5x squared, and the second 2 have to multiply to 4. So I found 5x times x is 5x squared, and 2 times 2 is 4, and I rewrote this in factored form. Okay, look at their work. What is the misconception? What were they thinking? And let's get back to like the initial one. It was 5x squared plus 21x plus 4. So is this correct? Why or why not, right? And no, it's not correct, because when you multiply these out using the box method, you're going to get 10x, you're going to get a 12x in the middle. This part works and this part works, but the B term is a term that doesn't work. So we have to try another combination. Are there other combinations of 5x and x that multiply to 5x squared? No, there's no other pair of factors that can multiply to 5x squared. Is there a combination of different numbers that can multiply to 4? Yes, there are. So that's where you have to try different factors. You may have to try multiple times. And this student could have multiplied this out, and they could have found that it was 12x plus 4. And then they would have said to themselves, okay, this doesn't work. Let me try something else. I know that these last 2 have to be 4. Let me try 4 and 1, or let me try 1 and 4 and see what happens, right? So the misconception is that they're not looking at the B term. They're not thinking about the B term when factoring. They're only thinking about they have to multiply to the first term and the last term. But they're not thinking about the B term and what has to be added to get to that term, okay? And you want to get students a chance to answer that and students a chance to share out the misconception. You might even use a think, pair, share here and give students the space and opportunity to go into a breakout room and discuss as a team what the misconception was. Okay. And then the last one is kind of the misconception in the reverse, right? So this student is thinking, I have to find a pair of numbers that multiply to 4 and add up to 21. They're ignoring the fact that this is a 5. They're going back to what they learned before we got to an A term greater than 1. So they're holding on to that procedure that they maybe learned in a different class or started to use. They may not be making this product sum chart, but this is just a way that you can see this misconception very clearly. And so the students like looking for different factors, but they're finding that they cannot get a sum of 21. No matter what factors of 4 they find, they can't get a sum of 21. And then when they started trying to find sums of 21, and they can't get a product of 4. So they're kind of working in this really inefficient way. And then they come to the conclusion that no 2 numbers add up to 21 and multiply to 4. So they just don't know what to do, right? And that could very well happen. They may not show their work this way, but you can try to find someone who is clearly thinking in this way and forgetting about the first term. And that's a conversation and a discussion you can have with students. By taking the time to really address these 2 misconceptions, it's going to prevent students from making those mistakes in the future and push them to really think about the entire expression. And really also, if you want your students to use the diagrams, that's a great strategy to feature to show them a way to organize their work. You can also show other strategies as opposed to showing misconceptions if the misconceptions are not arising in your class and students seem to have an understanding. Okay, so in summary, this is a very challenging topic for a lot of students, but giving them the space to really use guess and check and think deeply about the concept, and also then taking time to reflect on misconceptions, is going to provide them with a very solid foundation within this skill set. And then in future lessons, they will continue to practice it and apply their knowledge.